Finding limits algebraically. So the first thing we want to do is, before we get into the real algebraic techniques, is take a look at how you're going to find limits given a piecewise function. Remember back in Unit 7, we talked about how to graph and evaluate piecewise functions. Remember, you're given a function with a restricted domain, and then you may have more than one function in there. So now, remember, when you take a look at a limit, so the limit as x approaches 2, again, you see that plus sign. So what side are we going to be looking at, to the right or to the left? To the right. So now remember, when I say to the right of 2, are we looking at x values larger than 2 or smaller than 2? Larger. So what we need to do then is to find the limit as x approaches 2 from the right. We need to look at the domain that talks about x values that are larger than 2. So which domain represents x values larger than 2, the first one or the second one? The second one. So all I'm going to do is I'm going to plug 2 into the second part of my piecewise function for x. So what is negative 2 plus 2 going to give me? 0. So there's the limit as x approaches 2 from the right. So now when I take a look at b, this is the limit as x approaches 2. Now you see the negative exponent. So what side are we looking at, the left or the right? Left. And when I say to the left, are we looking at x values larger or smaller than 2? Smaller. So I need to find the domain where my x values are less than 2. So which domain is this one going to fit into? It's going to fit into the first one because that's where x is less than or equal to 2. So all I'm going to do is I'm going to plug in 2 into that particular function for x. So 3 minus 2 squared, which is going to give me a negative 1. So any questions on how I found the answer to part B? So now taking a look at C. The limit as x approaches 2. What side am I looking at? Left, right, or both? Both. So I have to look at the both. Remember, for this to exist, the limit as x approaches 2 from the right has to be equal to the limit as x approaches 2 from the left. So remember, in order for this two-sided limit to exist, what happens on the right and the left has to be the same. Are they the same number? You already found left and right in A and B. Are they the same number? No. So we would say that this limit does not exist. All right? So if the values are not the same on the left and the right, then remember the two-sided limit does not exist. All right? Let's take a look at 2. The limit as x approaches negative 1. Now what side are we looking at? Left, right, or both? We're going to be looking at the left, which means we're looking at the x value smaller. So again, where are we smaller than negative 1? That's going to be in the first equation. So I'm going to plug negative 1 into x squared plus 3. So negative 1 squared plus 3. So what's negative 1 squared plus 3 going to give me? 4. So now the limit as x approaches negative 1 from the plus sign. What side are we looking at? Left, right, or both? Right. And again, when I say from the right, I want to know where we're larger than negative 1. So now in this case, I'm going to look at my second equation because that's where my x values are greater than negative 1. So 3 minus a negative 1. 3 minus a negative 1 is going to give me a 4. So now notice in C, this does not have a plus or a minus as an exponent. So that means that I'm going to have to look on which side, left, right, or both? Both. And remember, for this to exist, the limit as x approaches negative 1 from the left has to be equal to the limit as x approaches negative 1 from the right. So for this two-sided limit to exist, remember what happens on the left has to be the same as what's happening on the right. If they're different numbers, remember it's a D and E. So what is this limit as x approaches negative 1 going to be? 4. Okay? So now take a look at number 3. Does the limit exist at x equals 0? So what this is asking you is to find the limit as x approaches 0 on both sides of f of x. That's what this question is asking you for. So does the limit, so you guys go ahead and look at this one. For this limit to exist, what side are we going to look at? Left, right, or both? Both. So you guys go ahead and tell me if that limit as x approaches 0 is going to exist or not. So we come up with 0 for that one? All right. So any questions on how you can find a two-sided limit from a piecewise function? Now, what about the limit as x approaches 1? Well, first of all, to find the limit as x approaches 1, again, which domain does 1 fit into? Does 1 fit into the first, or does it fit into the second? The second. So how am I going to find this limit? I'm simply going to do direct substitution. So 3 times 1 is going to be equal to what? 3. And you're done. All right? So any questions on finding limits of piecewise functions? All right. So like I said, what we're going to talk about today, guys, is we're going to talk about algebraically finding limits. You have to be able to do limits 3 ways. Graphically, which you had practice last night for homework. You had some practice with direct substitution, and then you had practice with tables. So like I said, the first method that you're going to always try when you're trying to find limits algebraically is to do direct substitution. So again, direct substitution is just that. It doesn't matter if you're coming from the left or right. You always take this x value and just plug it in for x. If you get a number out, you're done. So negative 1 squared plus negative 1 minus 6. So 1 minus 1 minus 6. So what's that going to be equal to when you have 1 minus 1 minus 6? That's going to be what? Negative 6. Okay? So now take a look at 2. Again, plug in negative 1 for x. So negative 1 squared plus negative 1 minus 6 divided by negative 1 plus 3. So 1 minus 1 on the numerator gives me a 0. 0 minus 6 is a negative 6 over negative 1 plus 3, which is 2, so that's going to give me a negative 3. You guys go ahead and try the next 4 for me on your own. So any questions, guys, on 3 through 6, being able to find limits through direct substitution? Like I said, direct substitution does not always work. The only time direct substitution is going to work is when the limit is the same as the defined value, which does not always happen. That's the only time direct substitution is going to work. So that's where we're going to have these other algebraic techniques. So another method you're going to try is factoring and cancel. You always try direct substitution first. So if direct substitution fails, that means what happens is you end up with a 0 in the numerator and or the denominator. So just because you end up with a 0 in the denominator or a 0 and or in the numerator does not mean the limit is undefined. That means you have what's called the indeterminate form. Yes, Kieran?
How is direct substitution not work?
If you have a hole in the graph or you have a jump, remember, limit is not equal to the defined value all the time. Yeah, so if it's not, the limit's not equal to the defined value, then that's when direct substitution is not going to work. So let's suppose you try direct substitution and you end up with 0 over 0. That doesn't mean the limit does not exist. That's what we call the indeterminate form. That means that basically you don't have enough information to talk about the limit. So that's where you're going to have to try one of these other algebraic techniques. So for example, let's take a look at the limit as x approaches 1 of x squared minus 1 over x minus 1. So now this is where factoring and cancel is going to come in. So obviously if I try and do direct substitution, I plug in 1 for x. What happens when I plug in a 1 for x here? We end up with a 0 over 0. So that doesn't tell us anything about the limit. Yes, I know that at x equals 1, this function is not defined. But it doesn't say anything about the limit. So this is where you want to check to see if you can do some factoring. Can you factor x squared minus 1? What does x squared minus 1 factor into? X plus 1 and an x minus 1 over x minus 1. So we just, in the last unit, we took a test on what's happening here at x minus 1. Do you have an asymptote or do you have a hole? You have a hole because notice you can cancel out that x minus 1. So once you do your factoring and cancel, try your direct substitution again. So when I try and do my direct substitution again, I'll plug in a 1 for x. What is 1 plus 1 equal to? 2. So there's the limit. So what's happening, remember, is you found the y value of the hole. All right? So now let's take a look at what's happening with the limit from the table. So again, I'll go to my y equals, and I'm going to type in my function, x squared minus 1 over x minus 1. So when I type in, I'll just delete those values out, 0.9, that gives me 1.9. When I type in 0.99, that gives me 1.99. When I type in 0.999, that gives me 1.999. So as you can see, the closer you're getting to an x value of 1, the closer your y values are approaching 2. So then if I look at my x value slightly larger than 1, 1.001 is 2.001. 1.01 is 2.01. And then 1.1 is 2.1. So as you can see, as your x values got really, really close to 1 that are slightly larger and slightly smaller, look at those y values, you're getting really, really close to 2. Now remember graphically how we graphed x squared minus 1 over x minus 1. Remember graphically what you'd be doing is graphing the whatever the fraction is that's reduced. But remember, like I just mentioned, you have a hole at 1, 2. So when I go to graph this particular function, so remember we talked about the limit as x approaches 1 of x squared minus 1 over x minus 1. We found we have a hole at 1, 2. So remember how we plotted these functions with a hole? We just put an open circle at that point. And remember, graphically, we're just going to graph y equals x plus 1. You have a y-intercept of 1. So remember, this equation just represents the line with a hole in it. So notice what's happening with the limit as you're approaching 1 from the left and to the right, you're approaching the y value of the hole. All right? So again, yes, it's not defined at 1, but limits don't care about the defined value. We want to know what's happening as you're getting really, really close. So like I said, if direct substitution doesn't work, you see if you can factor and cancel the fraction. Yes, Emma?
How did you get the point on 0, 1?
The y-intercept, because again, we're just graphing the line y equals x plus 1. So now let's take a look at number 1. Like I said, you always try direct substitution first. So if I try plugging in negative 3, I know that negative 3 squared is 9. 9 minus 3 minus 6 over negative 3 plus 3. So what happens when I plug negative 3 in? What do I end up with? I end up with what? 0 over what? 0. So again, it doesn't tell me that it does not exist or undefined. What I now want to try and do is I want to factor. So how do I factor x squared plus x minus 6? That's going to factor into x plus 3 times x minus 2 over x plus 3. Now cancel your fraction. You can cancel out the x plus 3's. So after you do your factoring and your canceling, now try your direct substitution again. So plug into my simplified form. So I have negative 3 minus 2, which gives me a negative 5. Okay. Like I said, you always still try direct substitution first. If that doesn't work, That's when you try your factoring and your canceling. So again, look at number 2. If I try and do direct substitution, when I square negative 4, that's going to give me a 16 minus 16 over negative 4 plus 4. So notice that gives me 0 over 0. Again, doesn't tell me anything about the limit. It does tell me, however, it's not defined at negative 4. So again, what I want to do is I want to factor. How do you factor x squared minus 16? That factors into what? X plus 4 and x minus 4 over x plus 4. And what can you cancel out? You can cancel out a what? X plus 4. So now you try direct substitution again. So negative 4 minus 4 is going to give me a negative 8. So this method will work when you actually have a hole in the graph. So this is when you have a hole in the graph, the limit exists, but I know it's not defined there. Okay? You guys go ahead and try 3 and 4 for me. It's factoring to find a limit. Like I said, notice I still check direct substitution all the time. All right? So any questions on fact? No, obviously not everything's going to be able to be factored. So there's another algebraic technique you can do, and that is rationalizing. You've been rationalizing denominators since Algebra 1. You can also rationalize numerators in the same technique as the way you rationalize denominators. It's pretty obvious when you're going to use this technique because you're going to see a radical in the numerator or the denominator. Again, you still always check direct substitution. Again, if direct substitution produces your indeterminate form. So again, you still always do direct substitution. If you get that indeterminate form, which means 0 over 0, but later on we'll talk about infinity over infinity. But right now we'll just be looking at 0 over 0. And a radical appears in the numerator or denominator. You're going to multiply by the conjugate and then evaluate by direct substitution. So very similar to what we just did with the factoring. After you get done factoring and canceling, once you get done rationalizing, try direct substitution after you get done the rationalizing process. So for example, let's take a look at number 1. The limit as x approaches 0. Again, always try direct substitution first. Well, if I plug in 0 for x, that's going to give me square root of 1 minus 1 over 0. So notice I do get that indeterminate form of 0 over 0. Where is my radical? Is my radical in the numerator or is my radical in the denominator? Numerator. So this is where you're going to have to multiply by the conjugate of the numerator. Don't forget what a conjugate is. A conjugate is when you have a binomial and you're just going to change the sign separating the two terms. So notice I've got square root of x plus 1. That's one term. You have a 1. That's another term. You don't change the sign that's underneath the radical. You just change the sign that's separating the two terms. So the conjugate of the numerator is simply going to be the square root of x plus 1 plus 1. Remember, you have to multiply the numerator and denominator by the conjugate to keep your fraction in balance. Like I mentioned, the conjugate, you only change the sign separating the two terms. You don't touch what's underneath the radical. The radical by itself is one term. The 1 is another term. So the only sign you're changing is the sign that's separating the radical and the constant. Any questions on what the conjugate is? But again, remember, you got to multiply top and bottom by the conjugate. Now remember, when you go to FOIL a binomial and its conjugate, what happens with the outer and inner terms? They're going to do what? Remember when you do the foiling of a conjugate, they do what? What happens? They cancel. So remember, make the foiling easy on yourself. Just multiply the first and the last terms together. What happens when you multiply square root of x plus 1 by itself? Square root of x plus 1 times square root of x plus 1 is just going to be what? X plus 1. The the last terms. Negative 1 times 1. What's negative 1 times 1? Negative 1. Do not worry about foiling or distributing the bottom. Leave it in factored form. So x times the square root of x plus 1 plus 1. So any questions on what I've got after I multiply by the conjugate? What happens in the numerator? What's going to cancel out? What cancels out? Well, what's 1 minus 1? 0. So I have the limit as x approaches 0 of x over x times the square root of x plus 1 plus 1. Can I simplify that fraction anymore? What's a common factor in the numerator and denominator that I can cancel out? X. So then I have the limit as x approaches 0 of 1. Remember, when you divide something by itself, it's not a 0, it's a 1. Over the square root of x plus 1 plus 1. So any questions on how I simplified that fraction? Now, try your direct substitution again. Plug in 0 for x. See if you get an answer out. So we have 1 over the square root of 0 plus 1 plus 1. Well, what's the square root of 1? 1. So I have 1 over 1 plus 1, which is 1/2. So there's your limit. Like I said, the conjugate is just flipping the sign that separates the radical and the other term in it. So any questions where I got the 1/2 from? So now take a look at number 2. Again, if I try direct substitution, that's going to give me a 0 over square root of 5 minus square root of 5, which will give me a 0 over 0. So now, notice the radical is not in the numerator, the radical is in the denominator. So I'm still going to try by multiplying by the conjugate. What is the conjugate of the denominator going to be? What is the conjugate of this denominator? Again, remember, this is one term. The square root of 5 minus x is one term. Square root of 5 is another term. So what's the conjugate going to be? Exactly. Square root of 5 minus x plus square root 5. So that's your conjugate. So I don't get squished. So now again, don't worry about distributing the x each term. Leave the x on the outside of the parentheses. So I have x times the square root of 5 minus x plus square root 5 over. Remember what happens when you multiply a binomial and its conjugate. You don't have to worry about multiplying the outer and inners. Just do first and last. What's the square root of 5 minus x times square root of 5 minus x? That's just going to be what? 5 minus x. Then your last terms. Negative square root 5 times positive square root 5 will give me a what? Well, negative square root 5 times square root 5 will give me a what? Negative, well, square root of 25 is what? 5, because 5 times, so it's going to be minus 5. Because again, all you're doing is multiplying negative square root 5 times positive square root 5. Okay? So any questions on where I got that from? So what's going to cancel out in the denominator? You're going to be able to cancel out a what? What are you going to be left with on the bottom? What are we going to be left with on the bottom?
X.
Not just an x, but a negative x. Now, how can you simplify your fraction? What are you going to be able to cancel out? You cancel out a what? Be able to cancel out a what? How can we simplify this fraction? What can you cancel out? Guys, I'm seeing a lot of unfocused people and people that I know are back from break, but you guys better wake up. You're having a quiz on this on Friday. All right? Stop me if I lose you. Raise your hand. What can you simplify this fraction? What can you cancel out? You can cancel out a what? X. So I'm left with a limit as x approaches 0 of square root of 5 minus x plus square root 5, all over a negative 1. Any questions on what I've done here? Now, try your direct substitution again. Plug in 0 for x. So square root of 5 minus 0 plus square root of 5, all divided by a negative 1. Well, I know 5 minus 0 is just a 5. How do you add square root of 5 plus square root of 5 together? That's just going to give you what? How do you add radicals together? 2 square root 5 divided by a negative 1, or negative 2 square root 5. Okay? I want to bring something to your attention, because inevitably somebody is going to get very upset with me when I hand back the graded quizzes on Friday. Notice, I am rewriting this limit notation every single step. You must write this limit notation each and every step until you actually do the direct substitution. All right? That is an operation. You would never drop an addition sign. You would never drop in a subtraction sign. You must write that limit notation. That is an operation you have to perform. Until you actually do direct substitution, this limit notation has to stay. And hopefully it's a reminder to you, because probably one of the most common errors I'll see on the quiz. You guys will do your conjugate and you'll get it down to this particular point, and that's what some of you are going to leave as your final answer. Because you guys forget to do that 0, do that last step of a direct substitution. You've got to do that last step. So hopefully that's also a reminder to you that you have to do that direct substitution as the last step. Those of you that take calculus next year, this is the introduction of what you're going to see at the beginning of calculus next year. Notation is huge. When they go to take your if you're going to take AB Calc and you take the AP exam, they are huge on notation. There are literally points deducted in the free response questions if the limit notation is dropped. So I've got to get you in the habit now of making sure you understand that this notation is huge. So I will deduct points if you drop this limit notation before you do that direct substitution for the quiz on Friday. All right, any questions on that? All right, so any questions on rationalizing? All right, last technique, complex fractions. Remember, a complex fraction is when you have a fraction in the numerator or the denominator. Again, we still always try direct substitution first. You always try direct substitution. But if direct substitution produces a 0 over 0, which is your indeterminate form, and again, it's pretty obvious you're going to have a complex fraction because you have fractions in the numerator and denominator. You're simply going to simplify your complex fraction by the LCD trick. Multiply everything by your LCDs. And again, your final step will always be direct substitution. Remember, after you simplify the complex fractions, you may need to do your factoring and canceling as well. So get that fraction in simplest form before you do direct substitution. So let's take a look at number 1. Everybody agrees with me, I have a complex fraction here. I've got fractions in the numerator. Try and do your direct substitution first. Well, if I plug in 0 for x, that's going to give me 1/5 minus 1/5 over 0. So I have 0 over 0. So now what I have to do is simplify your complex fraction. So this is where you're going to do your LCD trick. So notice in the numerator, one fraction has a denominator of 5 minus x. The other fraction has a denominator of 5. So your LCD is going to be what? What would the LCD then be between those two fractions? Looking at the top, what's the LCD going to be? Between these two fractions, what's your LCD? 5 times what? So you have this denominator is a 5, This has 5 minus x. So the LCD is going to be what? 5 times what? 5 minus x. So now what I'm going to do is multiply each of my fractions by that LCD. So 1 over 5 minus x, I'm going to multiply by 5 times 5 minus x. Minus, I take 1/5, multiply it by 5 times 5 minus x. Again, remember, you've got to keep that fraction in balance so that x on the bottom also gets multiplied by the LCD. Remember, what you're doing is multiplying by a fancy form of 1. The reason why you do this is because, remember, with the LCD trick, it's going to make all the fractions disappear. I can cross-cancel that 5 minus x. All I'm left with is a 1 times 5, which is a 5. Minus 1/5 times your LCD, I can get the 5s to cross-cancel. Be careful, make sure you leave that 5 minus x inside parentheses. Over, nothing's going to cancel out on the bottom, I have a 5x times 5 minus x. So notice the LCD trick gets rid of the fractions in the numerator. Simplify your fraction. Well, I know I can distribute the negative sign. I have 5 minus 5 plus x. What happens with the 5 minus 5? That goes to what? 5 minus 5 goes to what? 0. So I'm left with the limit as x approaches 0 of x over 5x times 5 minus x. Can I still simplify this fraction? What can you cancel out? You can cancel out the what? What can I cancel out now? X. So I have the limit as x approaches 0 of 1 over 5 times 5 minus x. Can I do any more canceling on that fraction? No. Now try your direct substitution again. Plug in 0 for x. So 1 over 5 times 5 minus 0. So what's this limit going to be? This limit's going to be 1 over what? 25. Okay. So if this is the part that you struggle with, guys, it's not what we're doing in pre-calc. Nothing that I did here with these fractions isn't something we haven't reviewed from Algebra 2. This is all algebra. If you're okay on what I did on this very last step, plugging in 0, it's not the new concept you're struggling with. You're struggling going back to the same old algebra, simplifying complex fractions. Because this whole idea in here has nothing to do with limits. It has to do with simplifying complex fractions. So if you need practice on simplifying complex fractions, you need to get in here Bruin block this week so that you're ready for the quiz on Friday. All right? The only new concept is when I found that limit, plugging 0 in for x. It has nothing to do with what we're doing in this unit right now. All right? So make sure you understand, is it the algebra or the new stuff that you're having trouble with? Most of this problem is algebra, just like the rationalizing problem is algebra. All right? Let's take a look at number 2. Again, if I plug in 0 for x, always try and do your direct substitution first. I have 1 over 1 minus 1 over 0. Notice that gives me 0 over 0. Notice I have a complex fraction because I have a fraction in the numerator. What's the LCD going to be here? Your LCD is going to be a what? What's the LCD going to be? X plus 1. So you guys go ahead and practice that. See if you can simplify that complex fraction for me. So now notice, ladies and gentlemen, I can do my distributing here. So now notice I've got to distribute. Make sure you're careful with that subtraction sign. So that's 1 minus x minus 1 over x times x plus 1. What can I do next? What can I do next here, guys? What can I do in the numerator? What's going to cancel out in the numerator? The 1s. So I have the limit as x goes to 0 of negative x over x times x plus 1. You want to get this fraction in simplest form. So now what else can you do with this fraction? What are we going to be able to cancel out? You can cancel out the what? X's. So that leaves me with the limit as x approaches 0 of negative 1 over x plus 1. Can I simplify that fraction anymore? No. So now what can I now try to do? I can do my direct substitution. Plug in the 0 for x. So negative 1 over 0 plus 1. And what's that limit going to be? That's going to be what? Negative 1. Okay? So any questions on those algebraic properties of limits? All right. So ladies and gentlemen,